two. Let's run this thing out a little bit more. 2 seconds. Let's run out for 8 seconds. So it's sort of like what this system might look like if we put some damper in there. Spring mass system. All right, so the true test of it is going to be if the V curve matches. So the V should start at 0, and everywhere that the X is a max, everywhere X is a max, what should V be? Calculus. And dynamics. What's the definition of V? Is what? It starts with a V. Velocity. So what's the relationship between X and velocity from your dynamics class? Derivative. So everywhere that X, if we got this right, everywhere X is a max, what do we know about the velocity? 0. It's got to be 0. So let's see if we can plots out correctly. All right, so first part, so we'll say that. Paste. So that's the derivative of the first part, and then I got that. If I did that right, we can tweak. There's a minus in there. So let's do my side. I think I need that to be negative. Say we're down to about 10% chances. Maybe it is working. It's pretty close to 0 where this is maybe a zoom right here. I call that a success. I think that actually works. I'm very surprised. Not really expected that at all. That's really unexpected. But I would say if you look at this one right here where that's 0, that's the velocity. That's the velocity. We do one more zoom, 5 minutes or so. Yes, it works. Okay. There's a mistake. There's a sign mistake I've done before, but I was too lazy to get up and correct it, so don't worry about that. Okay. All right. Everybody's cool with this? All right. So the real idea for this class, it's kind of funny too. Every time I teach that vibes class, I'm thinking people going through all this stuff, all this analysis. And one little MATLAB code can solve everything in this whole class. Pretty much, that's it. So don't underestimate the importance of this problem. All right, so what we want to do then is now we want to, I'm not going to retype all this, I'm just going to leave this in there. We got the exact solutions looking pretty good. What I want to do is let's use the Euler's method and see if we can crunch this same process out. Okay, and hopefully we can break this thing. Like, oh, I think we can break this thing pretty badly. All right, so let's. All right, so what we're going to do is I'm going to track two variables now, and it'll say, where's my velocity over here? I'm just going to got the T up there. I'm going to call it VEM for Euler's method. How about VEM? Here's a use of that comment. And also, as we come away from this class, when you say, y'all remember the football team, the Houston Oilers? It became my favorite team, the Tennessee Titans. When you see the word Oiler, just call it what it is. I mean, everybody calls, I've heard it like boogered up over the years, but just use the word Oiler. So it's like Houston Oilers. Okay. All right, so it stands for Euler's method. And that's going to be the velocity there. I'll say x e m. Any questions? All right. So in Euler's method, it's kind of weird, but these time steppers, they work if we track things kind of in a loop. So every time we jump up to a new x, we solve that differential equation. Those really paired differential equations, we're going to solve them at each time step of using that Euler's method. If that makes sense. Okay. All right, so what we're going to come down here is we need to also initialize. So we'll say it's going to be fair. And what I want to do, I'm not really so interested in these. I'll save all these right here. I'll just put a comment in here. So a long time ago, I did Fortran. My PhD advisor hated Fortran code with anything other than uppercase, so I got in the habit of doing uppercase. Did my postdoc at Oak Ridge, and the guy, he would just use lowercase. Somehow it just seems bad. So sometimes I put in comments in all caps. So we know that. So let's put in Euler's method. Okay, so what we had up there is we had an equation for V, and so let's see, V. Y'all tell me, I'm gonna put y'all on the spot a little bit, so we'll make which V is engaged as possible.